Hello everyone, let us see the solutions for Polytechnic Lecturer ECE 2024 question paper conducted by Andhra Pradesh Public Service Commission Part 4, Question 91. So given intrinsic concentration, electron concentration is 5 into 10 power 5 centimeter cube and conductivity is 8 mho per meter. We know that conduction current density or drift current density due to electrons Jn is nq mu into E electric field, but conductivity it can be given as sigma is equal to nq mu. So from the question they have given sigma is 8 mho per meter, sigma is 8 mho per meter, and electron concentration is 5 into 10 power 15. So 5 into 10 power 15 per centimeter cube, that is 5 into 10 power 21 per meter cube. So using this relation sigma is equal to nq into mobility. So 8 is equal to 5 into 10 power 21 into charge of electron is 1.6 into 10 power minus 19 into mobility. Therefore, mobility mu is equal to 8 by 5 into 10 power 21, 1.6 into 10 power minus 19. So its value is 10 into 10 power minus 3 meter square by volt second. Option 2 is a correct one. Next question. So which of the following agent is introduced into semiconductor to increase the carrier lifetime from nanosecond to microsecond? So generally, gold gold is added into the semiconductor. Once adding a gold to semiconductor decreases the carrier lifetime. So it is not increases, it decreases the carrier lifetime. This gold is a best recombination agent that speed up the process of electron hole recombination. So once electron hole recombination process get speed up, then the amount of free charge carrier that exists before recombining reduces. Gold is preferred over silver and other metals because silver will get and tarnish oxidized and tarnished, reducing the conductivity. Gold does not react significantly with any other component of air or plastic. Gold doesn't react with air or gold doesn't react with plastic used in integrated circuits even at elevated temperatures. Gold does not produce any oxides and other compounds so that it maintains its high conductivity even at elevated temperatures. These are the reasons. Hence, gold can be introduced into a semiconductor. So option 4 is a correct one. Next question. Which of the following equation represents the fact that within any elemental volume in a semiconductor charge neither created nor destroyed? So the fundamental law that governing the flow of charge is continuity equation. So continuity equation. So this continuity equation or law of conservation of charge or continuity equation for charge. So in this charge can be neither created nor destroyed. The continuity equation in a semiconductor describe how charge carrier concentration in a given elemental volume of the crystal varies with time. So that is charge carrier concentration in a body of semiconductor is a function of both time and distance. The continuity equation enables us to calculate the excess density of electrons and holes in time and space. So this is a continuity equation representation for holes and continuity equation representation for electrons. So increase in holes per unit volume per second is equal to increase in hole concentration per second due to thermal generation, that is P naught minus P by tau P, minus decrease in hole concentration per second due to recombinations 1 by Q dou Jp by dou X. Similarly, continuity equation for electron is dou n by dou T is equal to minus of n minus n naught by tau P plus dou n square by dou T square minus mu n dou n of U by dou X. So the correct option is continuity equation. It states that charge can neither be created nor destroyed. Next question. Which of the following statement is false regarding Zener diode? So in the question they have asked the false statement. So see the second statement. So for Zener diode, the direction of conduction is opposite to the arrow in the symbol. That statement is correct because Zener diode conducts electricity in reverse direction at Zener voltage in reverse bias. The junction break down the junction gets breakdown, allowing current to flow in the opposite direction. Statement 2 is correct. The location of Zener region can be controlled by varying the doping levels. This statement is correct. Zener potential of a Zener diode is very sensitive to temperature of operation. Correct. Zener diode voltage changes with temperature, so that is negative. It has Zener breakdown has negative temperature coefficient of voltage. So this is a arrow, this is a symbol for Zener diode, and arrow indicates the direction of forward current. So as Zener diode is designed to operate in reverse bias, the direction of current is opposite to that of arrow in the symbol, because Zener diode conduct electricity in reverse direction. Statement is correct. Statement 3. Zener diode is a heavily doped PN junction diode. The degree of doping determines the reverse voltage at which Zener breakdown occurs. So that is, Zener breakdown voltage is a voltage at which Zener diode conducts in reverse bias. Zener breakdown voltage is controlled by doping process. So doping and Zener breakdown are dependent on each other. Increasing doping level of Zener diode decreases the Zener potential. So if doping level increases, Zener voltage gets decreased. And the amount of doping in Zener diode, it controls the breakdown voltage and controls the location of Zener region. The amount of doping in Zener diode controls the breakdown voltage, controls the location of Zener region, increase in doping increases the impurity and decreases the Zener potential. So the statement 1 is false. Increasing doping level decrease the Zener potential. Decrease the Zener potential. In the question they have asked a false statement, so option 1 is correct. Next question, question 95. In a gallium arsenide diode, the greater percentage of energy converted during recombination at the junction is dissipated in the form of invisible light. So the statement is correct. Gallium arsenide diode typically emits infrared light. So in IR light is not visible to the human eye. So infrared lights in 850 nanometer to 950 nanometer range. So making it ideal for IR based applications such as remote control. So this IR rays cannot be seen by the human eye. IR rays cannot be seen by human eyes. So human eye cannot detect the infrared rays. So hence it is dissipated in the form of invisible light. Conclusion one given is used for security purpose where infrared light of remote control is an controlling element. The statement conclusion one is correct for the statement. So gallium arsenide phosphate GaAsP emit green light. The statement is wrong, because for statement 2, for conclusion 2, gallium arsenide phosphate GaAs1 minus X PX is a semiconductor material with heterojunction used for manufacturing red, yellow, and orange light emitting diodes depending upon the fraction x. This fraction x decides the color of light. The fraction x directly affects the bandgap energy of material, which in turn determines the wavelength of light. So IR rays cannot be seen by human eye. The color of emitted light will vary depending upon the fraction of x. So conclusion 2 is wrong. So this gallium arsenide phosphate either emit red, orange, and yellow light, but not the green light. So conclusion 1 true, conclusion 2 false. Only conclusion 1 follows. Next question. Gallium arsenide, gallium nitride GaN, it emits blue light. Gallium phosphide, it emits green light. Aluminum indium gallium phosphide, if aluminum concentration increases, it turns the yellow light into orange light. If indium content increases, it emits red light. Hence, aluminum, indium, gallium phosphide emits yellow, orange, and red light depending upon the relative concentration of aluminum, indium, and gallium. So, option 2 is the correct one. So, gallium nitride, it is blue light. Gallium nitride, it is blue light. Gallium phosphide, it is green light. Gallium phosphide, it is green light. So for option 3, gallium, indium, aluminum, indium, gallium phosphate, it emits yellow light depending upon the concentration of, depending upon the relative concentration of aluminum, indium, and gallium. Next question, question 97. A polycrystalline silicon solar cells are manufactured in a different, cheaper process and have low levels of efficiency. So that is assertion, and reason is gallium arsenide has high rate of absorption and higher energy conversion rate. So both statements are correct, and gallium arsenide has high optical absorption coefficient, that is, it absorbs lot of light in the thin layer. Both assertion and reason are correct, and reason is not the correct explanation for assertion. Option 2. Next question. In a common base configuration of bipolar junction transistor, what will be the value of collector current if base current is 0 and given alpha current gain? Alpha is current gain in common base configuration. Current gain in common base configuration is alpha, that is output current by input current. In common base configuration, base is common, base terminal is common to both input and output, and input terminal is emitter and output is collector. So we know that emitter current is collector current plus base current. In the question they have given base current is 0. Base current is 0. If base current is 0, then emitter current will become collector current, and the relation is collector current IC is equal to alpha IE plus ICBV. ICBO. So collector base junction leakage current. We know that base current is 0, hence IE is equal to IC. So IC is equal to alpha IC plus IC BO. So IC collector current into 1 minus alpha plus 1 minus alpha is equal to IC BO. So collector base leakage current is 1 microampere. Collector base leakage current is 1 microampere, 10 power minus 6, 1 minus 0.995. So its value is 0.2 milliampere. So collector current IC is 0.2 milliampere. What is the value of collector current is a question. Correct option is 2. Next question. The full form of the word CMOS used in transistor. So CMOS represents complementary metal oxide semiconductor. Complementary metal oxide semiconductor. So it can also be named as complementary symmetry metal oxide semiconductor. This is a CMOS structure is presented here. It consists of both NMOS and PMOS. The circuit that uses complementary pair of PMOS and NMOS is called CMOS. Next question. How many junctions are there in an equivalent circuit representing the junction monolithic capacitor, a type of mass capacitor? So the junction type IC capacitor is given in figure A. So it has two junctions, and the equivalent circuit is mentioned in figure B. There are two junctions. Junction monolithic capacitor is a type of CMOS capacitor that has two junctions. Junction monolithic capacitor. This monolithic capacitor is a type of CMOS capacitor that consists of two junctions. Next question. In the given figure, what does the dashed line between drain and source represents? So it is an MOSFET. We will see whether it is depletion MOSFET or enhancement MOSFET. So in MOSFET is of two types, that is depletion MOSFET and enhancement MOSFET. So depletion MOSFET again two types, P channel and N channel depletion MOSFET. Similarly, enhancement MOSFET is of two categories, N channel enhancement MOSFET and P channel enhancement MOSFET. In enhancement MOSFET, no channel exists between source and drain if no voltage is applied. That is, it requires reverse voltage to form an inversion layer or induce charge carriers in the channel. So given diagram is E MOSFET, enhancement MOSFET. That's why broken lines are given. These broken lines indicates channel does not exist between the two, that is drain and source, under no bias condition. In enhancement MOSFET, channel is constructed during manufacturing process itself, and the channel between source and drain exists even if there is no voltage is applied. Hence, continuous line exists between source and drain. Here, the line is continuous for D MOSFET, and broken lines represents enhancement MOSFET. So this is P channel and N channel E MOSFETs. Enhancement MOSFET, P channel and N channel enhancement MOSFET. This is P channel and N channel depletion MOSFET. Next, depletion MOSFET and enhancement MOSFET symbols are given. So this is a symbol for JFET, N channel JFET and P channel JFET. So three terminals, drain, gate and source. Drain, gate and source for N channel and P channel JFET. For N channel JFET, the arrow on the gate is towards and away from the gate. The arrow here is away and the arrow here is towards the representation between JFETs. So in the question they have given the dashed line between drain and source represents. So the dashed line represents it is a broken channel. That means if no voltage is applied, there is no inversion layer, no induce of charge carriers in the channel. No channel exists between source and drain if no voltage is applied. Next, we need to identify the transistor for a given symbol. So this is a symbol for JFET, junction field effect transistor, and unijunction transistor. This is a symbol, and 3 is for C unit junction transistor. Symbol is 3, matching is 3. For A n channel depletion type MOSFET, matching is 1. Here n channel depletion MOSFET channel is continuous. In D MOSFET channel is continuous, and P channel JFET. This is a symbol for P channel JFET. So next is unijunction transistor. This is a symbol for unijunction transistor. It consists of two base terminals B2 and B1 and emitter E. Constructional diagram and equivalent circuit of unijunction transistor. So correct option here is 1. Next question. Which of the following produces thin film of a single crystal silicon from the gas phase upon an existing crystal wafer of same material? So that is epitaxial growth. Epitaxy means it is a combination of two Greek words epi and taxis. Epi means upon, taxis means arrangement. So epitaxy is a process used to grow thin crystalline layer of a substrate. Epitaxy is a term applied to the process. It is a term applied to the process to grow a thin crystalline layer on a crystal substrate, or the method of growing crystalline layers on a substrate in a well-defined orientation. These are the different terms definitions for epitaxial growth. So epitaxial growth refers to the process of growing crystalline layer on a substrate, and various methods for epitaxial growth are, so these are the various methods for epitaxial growth: molecular beam epitaxy, chemical vapor deposition, liquid phase epitaxy, pulsed laser deposition, and solid phase epitaxy. And this epitaxy is again categorized into two types. One is heteroepitaxy and homoepitaxy. Heteroepitaxy means when a material is grown epitaxially on a substrate of different material, that is heteroepitaxy. Homoepitaxy means it is also called autoepitaxy, that is extension of substrate lattice by the overgrowth of layer of same material, such as silicon grown on silicon. Homo and heteroepitaxy, here they have given gas phase, so it is epitaxial growth. Option 1. Next question. Which of the following statement is false regarding ion implementation? So this ion implementation, so let us see the definition of ion implementation. Ion implementation is a process in which ions of a material can be implanted into another solid, thereby changing the physical properties of solid. So this ion implantation provides very precise control of doping. So it provides very precise control of doping. This statement is correct. In the question they have asked the false statement. Next, used for implantation through thin oxide layers. Ion implantation provides independent control of dosage and penetration depth. Ion implantation is non-equilibrium process, so that it is possible to introduce dopant into the semiconductor at a concentration in excess of their equilibrium solid solubility. So ion implantation is non-equilibrium process. Yeah, ion implantation provides independent control of dose and penetration depth. Ion implantation is very precise control of doping is possible here, used for implantation through thin oxide layers. Next statement 3. Thin oxide layer or aluminum mask may be placed over the areas where ion implantation is not desired. So this mask allows precise control over areas where ion implantation occurred. Ion implantation is carried out at room temperature. At a designed area of ion implantation, aluminum mask or thick oxide layer absorbs the ion. This statement is wrong. So wrong means false statement. False statement is correct option. The place where mask exists, ions cannot penetrate, and the underlying area is protected from the ion implantation. The areas not covered by the mask will be exposed to ion beam. The energy of ion determines the depth of penetration of the target. The statement is true. So ions of the proper dopant are accelerated to a high energy up to 30,000, so 3 into 10 power 6 electron volts. That is, statement is correct. Implantation energies are between 1 kilovolt, 1 kilo electron volt to 1 mega, that is 10 power 6 mega electron volts, resulting in, this is 3 mega electron volts, resulting in ion distributions with an average depth ranging from 10 nanometer to 110 micrometers. Average depth of ions is called range. So correct option is 3, which is a false statement. Next question. So SiO2, the SiO2 layer must be subjected to which of the following process to permit selective etching? So to permit selective etching is photolithography. First, we'll see the definition of ion implantation, epitaxial growth, and diffusion. So, ion implantation means dopants are introduced into a semiconductor by means of ion beam. So, diffusion means introducing dopants into a controlled amounts into the semiconductor substrate. So, diffusion used to form deep junctions at high temperatures. Ion implantation is used to form shallow junctions at low temperatures. Both this ion implantation and diffusion, both are complement to each other and is used to introduce impurities into the silicon wafer. Now, photolithography, the selective removal of material in silicon IC is called etching. This process is called etching, the process in which unwanted chemical, photoresist and silicon layers are removed at different stages of IC fabrication is called etching. There are four ways by which lithography is performed. One is optical lithography, electron lithography, X-ray lithography, and ion lithography. Photolithography involves two processes, namely masking of photographic mask and photo etching, used for removal of SiO2 from desired regions so that desired impurities can be diffused. Pattern transfer is accomplished by etching process that selectively removes unwanted portions of the layer. So correct option is photolithography. Next question. Question 106. In a photolithographic process, the exposed portion of photoresist film becomes. So we have seen the definition of photolithography here. The photoresist is a radiation, here they have given photoresist film. Photoresist is a radiation sensitive compound that can be classified as positive and negative photoresist depending on how it responds to radiation. So negative photoresist exposed the in negative photoresist exposed region undergo polymerization and becomes less soluble in developer solution, becomes polymerization. Negative photoresist compounds on exposure to light undergo polymer cross-linking reaction that becomes insoluble in developer solutions. After development, unexposed regions are removed and the patterns from negative resist are reverse of mask pattern. The exposed portion of photoresist film becomes polymerized. Polymer cross-linking reaction undergo polymerization. So correct option is 1. Next question. What is dynamic AC resistance? So dynamic AC resistance is a it is defined as the resistance offered by a semiconductor diode when AC supply biases the diode. So that is, instead of when AC voltage is applied across the diode offers some resistance. That resistance is dynamic AC resistance. It is given as ratio of change in voltage to change in current across the diode. That is, dynamic resistance RS is equal to delta V by delta I. So given delta V change in voltage is 0.075 volts and change in current delta I is 17 minus 2, that is 15 milliampere. 0.075 volts and 15 milliamperes. Dynamic resistance or AC resistance. Dynamic AC resistance RAC is equal to delta V by delta I, that is 0.075 by 15 into 10 power minus 3. So its value is 5 ohms. Next question. 5 ohms. Correct option is 108. So which of the following clamper circuit is given, and for the corresponding clamper circuit, what should be the output voltage? So the clipper circuit is given, and for the corresponding clipper circuit, what should be the output voltage? So generally these clipper circuits are used to remove unwanted portions of a signal. The purpose of clipper is to remove unnecessary portions of the signal. So clipper clips or removes unwanted portion of signal without distorting or disturbing the remaining portion of the waveform. So different types of clippers are there. Series positive clipper, This is a classification of clippers, series clippers and shunt clippers. So in shunt clippers, the diode is connected in parallel to the load. In series clipper, the diode is connected in series with the input signal. So this series clipper again of four types: series positive clipper, series negative clipper, series positive with biasing. These two are without biasing, no bias. Series positive and negative clipper with no bias. Positive and series positive clipper circuit and series negative clipper circuit with no bias. Similarly, positive clipper circuit and negative clipper circuit with biasing, that is positive bias and negative bias. Similarly, shunt positive clipper circuit, shunt negative clipper circuit, shunt positive biasing, shunt negative biasing. These are the different types of clippers. Let us see the diagrams for this series positive clipper. So this is series positive clipper. The diagram of series positive clipper. The diode is connected in series with the input. Diode is connected in series with the input. Similarly, shunt clipper means the diode is connected in parallel with the load. Okay. So series clipper without bias. Series positive clipper without bias, no bias, and series positive clipper with negative bias, series positive clipper with positive bias. Similarly, series negative clipper with positive bias, series negative clipper with negative bias. Next, shunt positive clipper, shunt clipper or parallel positive clipper, shunt clipper or parallel negative clipper. So diode is facing towards the ground. Shunt positive clipper with positive bias, shunt negative clipper with negative bias. So here there is no voltage source directly connected to ground. So this is parallel negative clipper with positive bias, parallel negative clipper with negative bias, and dual clipper. Two diodes are used. Two top and bottom portion of waveform is clipped off. So the circuit given. So from these series clippers, series positive and negative clippers with and without bias, shunt positive clippers and shunt negative clippers with and without bias. The given circuit diagram is parallel clipper, parallel negative clipper with positive bias. It is parallel negative clipper with positive bias. So given the diode is ideal, so diode is ideal means cut in voltage gamma v gamma is 0, and forward resistance offered by the diode is 0, and the reverse bias resistance offered by the diode is infinity. In forward bias it is short circuit, in reverse bias it is open circuit. So when vi is greater than 6 volts, for vi greater than 6 volts the diode is open circuit. The diode is reverse bias. So diode reverse bias means open circuit. Open circuit means infinite resistance. So that is entire output. Now output voltage is, so the output voltage v naught is entire input voltage. So v naught is equal to vi. So in this case v naught is equal to vi. In next case, when input is less than 6 volts, so that is when input is less than 6 volts, the diode is forward biased. Diode is forward biased means for an ideal diode, it resistance offered by the diode in forward bias is 0 ohm, that is short circuit. Hence output voltage v naught is equal to 6 volts constant. So for vi greater than 6 volts, output is same as input. For vi less than 6 volts, output voltage is constant. So this is a graph, output curve for the given input. And the applications of clippers are applications of clampers. Next question, question 109. So identify the type of circuit represented in the image. Here bias is voltage source is provided. Some voltage source is provided. It means the circuit is biased. Next, the diode is connected in series with the load. So diode is connected in series with the load. Hence it comes under series combination, and it is a positive clipper. Positive portion of waveform is clipped. Therefore, it is biased series clipper. Biased series clipper, that is series positive, series positive clipper with negative bias. So series positive clipper with negative bias. Okay. series positive clipper. The given circuit is series positive clipper with biasing. Next question, what will be the maximum positive value of output voltage from the circuit if a square wave of 20 volts peak is applied to the circuit input? So given the circuit is clamper circuit. So this clamper is a circuit that adds DC level to an input signal. And the clamper circuit is also called DC restorer or DC reinserter or level shifter. This clamper circuit consists of diode, resistor, capacitor that shifts the waveform to a desired DC level without changing the actual shape of the signal. Again, these clamper circuits are categorized into two types, that is positive clamper and negative clamper. Positive clamper without bias and with positive bias and with negative bias. Negative clamper without bias, negative clamper with positive bias, negative clamper with negative bias. Different representations are given. Let us see the clamper circuits. This is a clamper circuit which consists of diode, capacitor and resistor. So positive clamper, circuit diagram for positive clamper, minus Vm to Vm input signal is shifted to 0 to 2 Vm. The DC level is shifted to Vm. Here DC level is 0 and DC level is shifted to Vm. So positive clamper with positive bias. So this is a positive bias. Positive clamper with negative bias. So the signal starts from negative voltage. Here the signal starts from positive voltage. So this is regarding positive clamper. Similarly, next is negative clamper. Negative clamper without bias. Negative clamper, this is a negative clamper without any bias. Negative clamper with positive reference voltage. Negative clamper with negative reference voltage. This is a positive reference voltage. Output starts from negative reference voltage. These are the 6 clamping circuits. So from this, the question given is positive clamper with positive reference voltage. In the question, the circuit represents positive clamper with positive reference voltage. For positive clamper with positive reference voltage, so the output voltage, the maximum output voltage V naught is 2 times of Vi, 2 times of Vi plus reference voltage. The reference voltage here given is 8 volts. So that is reference voltage is 8 volts and 2 times of input voltage. Input voltage is 20. Peak to peak input voltage is 20. So that is 10. 2 Vi or peak to peak voltage, that is 20 volts. Given they have given 20 volts peak to peak. So 20 volts peak to peak is 2 times of input voltage, that is peak voltage. So 28. So maximum output voltage is 28 volts. Correct option is 3. Next question. In an IC positive TTL NAND gate. So this is a, let us see the TTL NAND gate. This is TTL NAND gate. So in TTL NAND gate, these protecting diodes are connected in multiple emitter transistor to protect the transistor from damage due to excessive input voltages. The special feature of TTL is totem pole arrangement between Q3 and Q4. Between Q3 and Q4, a diode is placed. It is a totem pole arrangement at the output side of circuit. This is a specialty here. And diodes are clamped at the multiple emitters of transistor Q1 to protect the transistor from excessive input voltages, to protect the transistor from damage due to excessive input voltages. So this TTL circuit consists of 3 stages: multiple emitter input stage, and this is phase shifter stage, and this is active pull up stage or totem pole output stage. Active pull up stage or totem pole output stage. Okay. Now assertion is clamping diodes are often included from each input to ground with anode grounded. So with anode is grounded. So anode means positive terminal. The positive terminal is grounded. Statement assertion is correct. This is cathode. Next, these diodes limit positive voltage excursions at the input to a safe value. The reason is wrong because inputs are clamped with the diodes to limit negative voltage excursions. In the assertion they have given positive voltage. So assertion is wrong and assertion is correct and reason is wrong. Correct option is 3. Next question. What is the maximum output voltage for the circuit given if input voltage Vi is 1500 T? So input voltage is 1500 T. The given circuit is clipper circuit, parallel negative clipper with negative bias. So for parallel negative clipper with negative bias, this is a practical output waveform. Now maximum output is, that is Vm. Here Vm is 15. Vi is equal to Vm sine omega t. So positive peak is Vm and negative peak is V gamma, that is 3 volts. So 15 volts and 3 volts. Minimum voltage is 3 and maximum voltage is 15. So this option 1 represents minimum voltage and option 3 represents maximum voltage. Next question. A cascading amplifier has dash and dash then a single stage. So for a cascading amplifier, what happens to the higher cutoff frequency, what happens to the lower cutoff frequency? So in a cascading amplifier having n amplifiers, that is n identical amplifiers are in cascade, then upper cutoff frequency is fh star is equal to fh into 2 power 1 by n minus 1, and lower cutoff frequency is fl is equal to fl by 2 power n minus 1. Similarly, bandwidth of n stage amplifier is bandwidth of individual stage multiplied by 2 power 1 by n minus 1, and the voltage gain is product of individual gains, and phase gain is sum of individual amplifier phases. So from these, the upper cutoff frequency is decreased. For n stage amplifier, the upper cutoff frequency is increased and lower cutoff frequency is increased. If upper cutoff frequency is decreased and lower cutoff frequency is increased, if star is decreased and lower cutoff frequency fl is increased, obviously the bandwidth gets decreased. So that means gain increases. So let us take an example number. For n is equal to 2, upper cutoff frequency fh star upper cutoff frequency fh star is 0.64 times of upper cutoff frequency, and lower cutoff frequency fl star is 1.5625 times of lower cutoff frequency. For n is equal to 3, that means 3 amplifiers are in cascaded, then upper cutoff frequency becomes 0.51 times of individual stage upper cutoff frequency, and lower cutoff frequency will become 1.96 fl. So that is, if n value increases, number of amplifiers increases, upper cutoff frequency decreases and lower cutoff frequency increases. Bandwidth is the difference between upper and lower cutoff frequencies. Substitute n is equal to 2 here, n is equal to 2 here, n is equal to 3 here, then we will get that values. Then these values are obtained. So therefore, option 1 is a correct one. If there are n stages, higher cutoff frequency will become lower, decreased, and lower cutoff frequency will become increases, and bandwidth gets decreased or shrinks. Next question. Given circuit represents a DC load line with fixed bias configuration. So fixed bias configuration. This is a fixed bias circuit. Let us apply KVL at the input side for a fixed bias circuit. So that is KVL at input side. VCC is equal to IBRB plus VBE. So this is a KVL at input side. From this, base current, base resistance RB is equal to VCC minus VBE by IB. So this is a okay. So from the graph, VCE is equal to, from the DC load line graph, VCE is equal to DC load line. From DC load line, VCE is equal to VCC. This VCE axis is x axis and IC axis is y axis. VCE is equal to VCC supply voltage, that is when IC is 0, and IC is VCC by RC when VC is 0. The Q point curve gives base current IB. So here this is a Q point. So the Q point exists on base current curve IB, which is in between 20 and 30 microamperes. It is 25 microamperes. Base current is IB is 25 microamperes. So from this, base resistance RB for a fixed bias circuit is VCC minus VBE, base emitter voltage, by RB. So that is VCC is 20 volts, VCC is 20 volts, and VB is 0.7 volts divided by base resistance current IB, base current IB. So base current IB is 25 microampere. So that is 19.3 divided by 25 into 10 power minus 6. So its value is 772 kilo ohms. 772 kilo ohms. Correct option is 3. Next question. In BJT amplifier circuits, collector current is sensitive to beta, and collector current is sensitive to VBE. Collector current is sensitive to ICO. So that is, if beta increases with this beta value increases with increase in temperature, VBE decreases about 2.5 millivolts per degree per centigrade with increase in temperature, and ICO doubles for every 10 degree rise in temperature. If beta changes, VBE changes, and ICO changes with temperature, then collector current also changes with the temperature. So option 4, that is ICO is 4. It doubles for every 10 degree rise in temperature. ICO doubles for every 10 degree rise in temperature. So A match the following with 4, and VBE decreases about 2.5 millivolts per degree centigrade, that is 2 decreases with increase in temperature, and then beta increases with increase in temperature. Beta increases with increase in temperature. Correct option is 4. So that is A4, B2, C1. Also some more points related to stability. There are three definitions for stability: S, S dash, and S double dash. So S is stability. S is rate of change of collector current with respect to collector leakage current, keeping VBE and beta constant. Delta IC by delta ICO, keeping VBE comma beta constant. S dash stability factor is delta IC by delta VBE, keeping ICO and beta constant. Similarly, S double dash is rate of change of collector current with respect to beta current gain, keeping ICO and VBE constant. Three different formulas. So these two, S, S dash, and S double dash. Next question. Read the networks are quite stable and relatively insensitive to temperature variations, have low stability factors. So what is bias stabilization? So bias stabilization is a process of making Q point independent of change in temperature and changes in atmosphere. So if temperature changes and Q point is independent of temperature changes, then the process is called bias stabilization. So statement 1. Lower the stability factor, more sensitive is a network to variations in temperature. Statement 1 is wrong, because higher the stability factor, then only it will be sensitive to changes in temperature. If lower value will be the stability factor, then it is insensitive to the variations in parameter. So networks that are quite stable and relatively insensitive to temperature variations having low stability factors. If stability factor is low, the network is relatively insensitive to temperature variations. That is, higher the stability factor, the more the sensitive is a network to variations in parameters. Next, second statement. Good biasing arrangement is one that can stabilize the Q point so that amplifier can be used in a changing temperature environment. So a better bias circuit is one. It is used in better changing environment because better biasing arrangement stabilizes the Q point. Hence, this amplifier can be used in a changing temperature environment. So conclusion 1 is false and conclusion 2 is correct. Next question. Which of the following parameters is ignored while the mid-frequency response of a small signal amplifier? So in RC coupled transistor amplifiers, low frequency response is determined by input and output coupling capacitors, and high frequency response is determined by junction capacitors. At high frequencies, the effect of small capacitors, that is internal at high frequencies, the effect of small capacitors, that is internal junction capacitance, should be considered. But at medium frequencies, the large capacitors appear to be short circuit and small capacitors appear to be open circuit. Hence their effect is not considered at medium frequency. So small capacitor means diffusion capacitance and transition capacitance. High capacitors means small capacitor is internal capacitor, that is diffusion capacitance and transition capacitance. So only capacitive elements. Which of the following parameters are ignored, not considered, while mid-frequency response of a small signal amplifier? So in the mid-frequency response of an amplifier, this capacitive element is ignored. Next question. The differential amplifier has two separate inputs and two separate outputs, and the emitters are connected together. So statement is correct. It has two separate inputs V1 and V2 and two separate outputs VO1 and VO2 with emitters connected. So statement is correct. So this is a differential amplifier. This differential amplifier has two inputs and two outputs with emitters connected, and the output voltage is differential gain into V1 minus V2. V0 is the output voltage. So differential amplifier is also known as difference amplifier or op-amp subtractor. Op-amp subtractor is a type of electronic amplifier that amplifies the difference between two input voltages but suppress any voltage common to the two inputs. The circuit has two separate inputs and two separate outputs with emitter connected together. Common mode signal is one that drives both inputs of differential amplifier equally. So single-ended signal, double-ended, and common mode. So single-ended means signal is applied to either of the input, either V1 or V2, and other input is grounded. So that is single-ended. So suppose if V1 is grounded and input is V2 is applied, it is single-ended connection. Or if V2 is grounded and input is applied here, then it is also single-ended connection. So input is applied to one and the other input is grounded. That is called single-ended connection. Double-ended means if two opposite polarity input signals are applied, then the operation is referred to as double-ended. Common mode means if same input is applied to both inputs of differential amplifier, that is common mode signal is one that drives the both inputs of differential amplifier equally. So in common mode, two input signals are applied to a differential amplifier inputs that are of same phase, same frequency, and same amplified. So the two inputs have same frequency, same amplitude, and same phase that drive the inputs of differential amplifier equally. Now, if same input is applied to both inputs, then operation is called common mode. Statement is correct. Conclusion 1 is correct. If two opposite polarity signals are applied, then operation is referred to as double-ended. It is not single-ended. It is double-ended. Conclusion 2 is false. Only conclusion 1 follows. Next question. Calculate the frequency of oscillation for a RC phase shift oscillator with FET having feedback resistor R is 4 kilo ohms and capacitance is 7 nanofarad. So this is a circuit diagram for RC phase shift oscillator designed with FET, field effect transistor. So the frequency of oscillation is given as 1 by 2 pi RC root 6. So beta is equal to 1 minus is equal to 1. Here the beta value is minus 1 by 29. Amplification factor for FET to work an oscillator is the gain of FET or amplification factor of FET. This field effect transistor with the three terminals, drain, source, and gate, to work as an oscillator is it should be greater than or equal to 29. And these three RC circuits doesn't create a phase shift of 180 degrees. So substitute the frequency of oscillation here at resonant frequency. Okay. The frequency of oscillation is 1 by 2 pi. R value is 4 kilo, that is 4 into 10 cube, and capacitance is 7 nanofarad, 7 into 10 power minus 9 divided by root 6. So its value is 2.32 kilohertz. So correct option is 1. Resonant frequency is 2.32 kilohertz. Next question. Consider an ideal operational amplifier. What is the value of output V0 for a circuit if VCC is 15 volts and input voltage is 8 volts and R1 R2 are 5 and 10 kilo ohm respectively? Oh. So here there is no op amp without feedback. There is no feedback from output to input. So the given op amp has no feedback from output to input. So no feedback means this op amp is working in open loop mode. Therefore, in open loop, our op amp without feedback acts like a comparator. Vin is a input applied, that is Vin is input applied to non-inverting terminal, that is VA, and input applied to inverting input terminal is VB as per the figure. So therefore, if VA is greater than VB, So VA greater than VB. Input at non-inverting terminal is greater than input on inverting terminal. Then output of this operational amplifier is plus V saturation. So saturation voltage is supply voltage, that is VCC. Op amp driven into saturation. It is in open loop. Output of an op amp is either plus V saturation or minus V saturation. That is op amp is driven into extreme conditions. Output is VCC. If VA is less than VB, so voltage applied to the non-inverting input terminal of op amp is less than the inverting input terminal of op amp, VA less than VB, then output of an operational amplifier V0 is minus V saturation. So minus V saturation is minus VCC. So the correct option is plus 15 volts. So VCC is 15, input is 8 volts, and R1 R2 are mentioned. It is plus 15 volts.